Hello, welcome to this part of a tutorial. Today we're going to look at something very interesting. So I implore you to stay tuned and go through this video from the beginning to the end without skipping frames, because you have a lot to learn. So we want to look at how to model a multilateral well. Of course, this is something which is trending. So it's being used by most of the industries. Most of the oil and gas companies. Okay, so what is a multilateral well? A multilateral well is a well that has more than one lateral going out from the borehole and connecting the well with one or multiple reservoirs. So you can have a scenario where you have three laterals draining a particular reservoir. So instead of having just one borehole and then one lateral producing from that reservoir, you might want to maybe increase your production, and then you drill another. Instead of drilling another well entirely, but from the same borehole, you drill another lateral to connect to that reservoir. Another scenario is where you have more than one layer, like layer of your reservoir, and then you want to produce those layers from the same borehole. So in that scenario, you drill a multilateral. So those are the objectives of a multilateral well. I've mentioned two. The first is to produce a larger drainage area than a single monobore. Of course, when you have more than one lateral piercing a particular reservoir, then you'll be producing more. Your drainage area will be larger. Okay, and the other one is when you have multiple reservoirs and then you want to produce from the same wellbore. So you drill, you use this technology. Now the question is, how do you model that using a software, particularly the one we're using, Petroleum Expert Prosper? That's what I'm going to show in this tutorial. Stay tuned. Okay. First, like all other tutorials, the first thing you have to do is to define go to the options summary, and then for that let me use this. I go to options and options. Okay, here I have oil and water, but I want to do a dry and wet cast, so that's what I want to do. I'll leave all other things as they are. The only thing I'll change is this. So you come to reservoir section, you check your inflow type. This is single branch, so this is a monobore. So, but I want a multilateral, so I change this to multilateral well. Okay, that's all I'm going to change here. So I go done. Then the next thing is to input my normal PVT data and the normal way, So, but there's something that will change anyway, so just stay tuned. So my gas gravity is 0.63. My separator pressure is at 500. The CGR is at 0. The condensate gravity is at 50, the WGR is at 2, and the salinity is at 800,000. 1, 2, 3. Okay, and then the impurities: hydrogen sulfide is 0. We have carbon 4 oxide as 0.15, and we have nitrogen as 3.6. I have data to match this, so I'll quickly enter the data and then we'll continue from there. Okay, so this is our PVT data, which I'm going to use to match this. You can go through the data, but for want of time, let's just continue. You can pause the screen and look at the data later. So I'll go done, and I'll go regression, and I'm matching all. Okay, the calculation is done, and let's look at the parameters. I have a tutorial on how to choose the best parameter. I think I did that in one of my tutorials. So from what we have here, the tutorial, the correlation chosen for us is the Lee et al. For our gas gravity, so we'll proceed with that, and then I go done, and of course PVT is matched, so done. The next thing is I'm going to my equipment and data deviation survey. Okay, I'll select everything, but I'll select the surface and then I'll edit. Okay, so I'll just input this data and then we'll be back. Okay, so this is our data for the deviation survey. Okay, so I'll go next. The next thing I have is the downhole equipment. Okay, for the downhole, what we have is we have a tubing. Okay, for the downhole, I have a tubing. I have SSSV subsurface safety valve, then another tubing. So just enter values. The tubing is at 260 feet measured depth, and the internal diameter is 6. The roughness is where we'll leave the roughness where it is. The SSSV is at 4.5, and that's the internal diameter. The other tubing is at 1577 feet, and the diameter is also 6. Okay, so let's go. The geothermal gradient is the next thing we have here. And then we have at the surface that the temperature is 40, and at a depth of 1578 the temperature is 62, and the overall heat transfer coefficient is 3 because we're modeling a gas well. Okay, so we go done, and we can draw this to look at what's happening. Okay, so that's what we have. So I'll go done and done. Now the most interesting part of this is the IPR data, and that is where we'll actually define our laterals and everything. So stay tuned, and if you've skipped other sections, please don't skip this one, because this is the heart of the tutorial. If you miss this, then you've gained nothing in this tutorial. Okay, so I go to our IPR data, and wow, this is the screen I am having. It's different from the other screens which we used to have. Okay, that is because we are going to draw a multilateral. If you've used gap before, this window should not be very strange to you. Of course, this is how gap looks. So the window of gap, it has controls here. So the first one here is defines your tie point, which is from the point where the laterals begin to split, where you're tying your laterals, you're tying your downhole, the laterals to the main bore. The next icon here is the group, which defines the point at the point where your laterals begin to split and where they join, after splitting, the point where they actually split. And the next one here is the completion, and this is what you use to define your laterals, their properties, the perforations and all that. The next thing there is the reservoir, so you also define your reservoir using this. You use this to link, these are connections, and these are zone tools and all that. Okay, so that is what we're going to do. You're going to define this. So I'll click on this icon, I click on the first one, the tie point, and I click anywhere on the screen to add that. So if I click on this, I'll give it a label, and I will just call it tie points. Okay, so I go done. Now the next thing is I'll add a group. Okay, the same thing, just click on the icon and click anywhere on the screen. So I'll call these what do I call it? I call it junction. Okay, now the next thing is to define the laterals. I have my first lateral here called lateral 1, and the other one here called lateral 2. Sorry for that. Lateral 2. Okay, so that's what I have, and then I have just one reservoir because these laterals are draining the same reservoir, so I'll call this reservoir. Now the next thing I have to do is to connect this. So I'm connecting the tie points to the junction, and the junction to the laterals, because you see what I'm doing, and then the laterals to the reservoir. So you just click and drag. Okay, so when we get to gap, you'll do a lot of this. I have not published tutorials on gap yet, but for now I'm still working on tutorials on that, and I'll post it very soon. So this is what you'll be doing. Okay, that's how to define that. I'll want to move these icons and align them better, so I use this move tool. If I move this one a bit here, at least to make it straight a bit, okay, I might decide to bring this one down a bit and this one here. Okay, but all these are not necessary anyway. It doesn't affect anything you're doing. It's just visual, something you're trying to improve the visual display of this. Okay, so now we've defined this. The next thing we have to do is to supply data. If you over any of this, if you mouse over any of these icons, what you'll be seeing is data invalid. Of course, data invalid, data invalid, data invalid, and all that. So what we have to do is to supply data for all of them. I will start with a tie point. Now look at this screen here. You see everything is marked X, meaning there are no valid data supplied. As you supply valid data, they should change to the green tick icon. Okay, having said that, let's continue. Now for the tie point, the measured depth is at 1577. Of course, that is from our deviation survey, that is where we defined this up to. In fact, our download equipment also stopped here. Okay, and then the true vertical depth that corresponds to this was 1398.4. okay, so I am done with supplying data for that. If I click on this again, it it shows the green tick icon. Of course, that's what I told you. And if I mouse over, it shows data valid. Okay, the next thing I have to is this tubing. This is my tubing. So tubing 1, I'll have to supply data for that too. Okay, so what I'm going to do is I'll click on this input data. I supply data for the deviation, then supply data for the tubing data, the equipment. So the deviation I have at 1577 has already been defined, and the next one is at 1650, where we have a TVD of 1424 and an azimuth of 230.6. okay, that is that. I go down. The next thing is the data is not valid. What's that? No complete equipment information has been entered. Okay, sorry, I was supposed to click this equipment. Sorry for that. Okay, the equipment I have here is the a tubing. The tubing is at a measured depth of 1650. The tubing inside diameter is 7, and we will leave all other things the way they are. So I go done, and if I over this, it says data valid. Okay, the next thing which I have to supply is my joint data, the junction, and the measured depth is at that and this. So I think that has been defined. I go done, and it says data valid. Okay, now the next one is where I define my laterals. So I'll click on lateral 1, and then I proceed with that. Okay, the lateral 1, I'll have to supply a wellbore radius and the dash shift factor. Of course, our dash shift factor is 31.6, and the wellbore radius for lateral 1 is 0.354 feet. Now I have to select a model, input data for the deviation survey, the equipment, and perforation details. Okay, so I'll start with the deviation survey. The deviation survey, I have some data which will take time to type, so I'll just input the data and we'll be back. Okay, so those are the data, the deviation survey data. Next I have to supply is the equipment data, and the equipment I have here is just a tubing. The tubing is at a measured depth of 1900, and the internal diameter of this tubing is 3.5. The roughness remains where it is. The perforation details, I need to supply the perforation, the measured depth where I begin the perforation, and I'm starting my perforation at 1650 and ending the perforation at 1900. Of course, the software will supply this, calculate this for me. So the software has actually calculated the TVD equivalent to the end and the start depth. Okay, the next thing is I'll have to choose a skin model, and I want to enter by hand, non-desi. Okay, so I'm entering my skin, and the skin I have here is 0. Okay, the skin is at 0. The non-desi flow factor is at 2.80 exponential minus 10. Okay, so that is all I have to supply for this, and once I click on done, if I validate, it will show that the data is valid. Data on the screen valid. Okay, so I'll go done, and if I mouse over this, it says data valid. So I'll do the same thing for this other one. The wellbore radius is the same as the other one, 0.354. Oh, sorry for that. At 0.354, and the dash shift factor remains the same at the 1.6. So I'll input the data, first the deviation, then the equipment, and then the perforation. So I'll just input the deviation and then we'll be back. Okay, these are the data I have for the lateral 2. The equipment data is what I have to supply now, and I have just a tubing. The tubing is at a depth of 2483. The inside diameter of this tubing is at 4. Okay, the next thing is that the perforation details. And of course I have to supply start depth, which is at 1670, and the end depth at the end there is at 2483. Okay, the other ones, like I said, will be calculated by Prosper. The skin is at 0, and the non-desi flow factor is at 2.80 exponential minus 10. Okay, that is all. And I go done. So lateral 2 says data is valid. Then the last one which I have to supply is the reservoir, and I'll supply the pressure, which is at 557. The temperature is at 65. The condensate gas gravity is at 50. The gas gravity itself is at 0.63. The water salinity is at 100. Oh, sorry, adding that. At 100,000. The condensate gas ratio or water gas ratio is at 2, and condensate is at 0. Okay, I'm done with that. So I'll have to supply the input data, which defines the permeability is at 244 millideci. The thickness is 50 feet. Drainage area is 500 acres. The reservoir top depth is at 1400. The vertical permeability is at 25. The reservoir porosity is at 0.28, while the connect water saturation is at 0.25. Okay, that's all, and it's showing data valid. Okay, so I have supplied this data. The next thing which I have to do is to calculate the IPR. But before I calculate, I would love to visualize this. Let's look at this, and let's look at all the views we have. So if you look at this is the network, what we just defined, and this is how it looks like when you're viewing from the top. So the reservoir top, and this is the front view of our model. So you see, this is our group, this is the tie point and all that. So this ties to the main bore, and then you have, this is the top view, and then this is the side view. Of course, that's how it looks. Okay, the next thing which we have to do is to analyze. So I'll just go calculate. So I'll change this from 1 point to cuff, and then I'll click on calculate. Okay, while it's calculating, let's look at this. You said the minimum pressure for this should be at 10, and the maximum pressure should be at this. The maximum pressure is, of course, the reservoir pressure. So the minimum pressure is the smallest pressure you can think of can exist, and then the number of points which you want the IPR to use in calculating and all that. So we're choosing 20 points, and that's what we're going to use. Okay, so we'll just allow this to calculate, and then we'll be back. Okay, our calculation is done, and this is the IPR. Of course, this is how it looks like, and then we have our absolute open flow potential to be 79.143 million standard cubic feet per day. Oh, okay, not bad. So that is what we have, and of course this is the data what on the calculation. So 20 points, and then the smallest pressure is at 10, and the highest pressure is at 556, which is our reservoir pressure. So we are done with that. So this gives us, okay, the calculation per layer. Okay, so I'll go done, and that is all I have to do here. So I'll finish, done, and this is our IPR. So that is how to model a multilateral. The next thing which you normally want to do is to calculate the production from the reservoir and all that. So, and that is what you know how to do already. You go to calculation, system, IPR and VLP, 3 variables, and okay, so you have to supply a top node pressure, and our top node pressure is 200. Okay, we go continue, not doing any sensitivity, so we go continue and calculate, and of course the calculation is finished, and we have gas rate of 54.844 million standard cubic feet per day. Okay, okay, that's that. You can actually plot that to see what's happening, system plots, and that is what you have. Now the value you're having here is showing the overall contribution from the different laterals. You might be interested and want to know the contribution of each of the laterals. What is the production from lateral 1 and what's the production from lateral 2? And to do that, all you have to do is to go to solution details, okay, and then you go to inflow layer details. So if I click on this, it will show you the production. So branch summary. Lateral 1, the rate contribution is at 13.533, and the rate contribution for lateral 2 is 41.311. okay, and this is the pressure drop from the different laterals, and this is the reservoir, the layer summary, and all that. You get a lot of details from here, and you can select this for look at the segment details by branch. So the first one is 41, which is our pipe, the pipe that links the tie point to the group, the junction. Okay, then lateral 1, lateral 2. So just play around with this and look at what's happening and all that. So that is our tutorial. Thank you very much for watching. More tutorials are actually loading, so I'll implore you to subscribe, that is if you have not subscribed already, and then go through the videos. If there are things you need us to improve upon, like maybe the voice quality, like someone pointed out the other time, so please tell us these things so that we'll be able to serve you better. Thank you very much for watching, and bless you. Don't forget to subscribe. Bye.